Alright, so a long time ago, this super smart guy came up with this theorem called the Fundamental Theorem of Algebra. And it's called fundamental for a reason. It is really fundamental. His name is Carl Gauss. He has sevens all over his stuff. He was born in 1777. He died at the age of 87. At the age of 17, he got his PhD. He wrote his PhD thesis. And for his PhD thesis, he proved exactly this theorem. He went on to become one of the most famous and most celebrated mathematicians of all times. They call him the Prince of Mathematics. An amazing guy. I heard he was a little arrogant and cocky, which I like. I like the attitude in people. Anyways, an amazing guy. He proved it for his PhD thesis at the age of 17, the Fundamental Theorem of Algebra, which says, roughly speaking, that if you look at a polynomial equation and if you want to know how many solutions does it have, it's so easy. All you could do is look at its degree. That's it. If you look at its degree, you will know exactly how many solutions it has. Kind of like this. Suppose I have this equation. This is degree 1, right? You see x with a power of 1. So therefore, the Fundamental Theorem of Algebra, according to Gauss, who proved it at the age of 17 for his PhD thesis, this is degree 1. So therefore, it should have one solution and one solution only. What is that? Well, it's easy. You add 2 to both sides and the solution is x equals 2. I told you, one solution. So easy, huh? If you have x squared minus 2x is equal to 0, look at that. That's degree 2. That's degree 2. Right there, degree 2. So according to the Fundamental Theorem of Algebra, I should have 2 solutions. Well, what are the 2 solutions? Well, it's easy. I could factor out an x. I would have x minus 2 is equal to 0. This is by distributive law. And now I have something times something is equal to 0. It's time for the zero factor theorem. So x equals 0 or x minus 2 is equal to 0 by the magical and wonderful zero factor theorem. And look at that, there's your solutions, x equals 0 or x equals 2. Actually, both work. Try it. If x equals 0, what's 0 squared minus 2 times 0? I told you, 0. 2 also works. 2 times 2 is 4, minus 4 is equal to 0. See why they pay me? Perfect. Degree 2, 2 solutions, Fundamental Theorem of Algebra. Wait, there's more. This is degree 3. What? Degree 3. According to the Fundamental Theorem of Algebra, how many solutions will you have? You have as many as its degree. Its degree is 3. So we need 3 solutions. Well, what are they? Well, as you know, this is a famous polynomial that has a famous factorization. It's a geometric series polynomial number 3 from our famous list. So now I have something times something is equal to 0. What? Something times something is equal to 0. What time is it? Zero factor theorem time. It's magic time. X minus 1 is equal to 0. Or x squared plus x plus 1 is equal to 0. By the zero factor theorem. And now I've traded my degree 3 problem for a couple of problems. One of degree 1, one of degree 2. So x equals 1 here, x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. Magical power of the quadratic formula. Now count them. This is degree 3, so we should expect 3 solutions. There's one of them, x equals 1. There's another one, x equals negative 1 plus the square root of negative 3 over 2. And there's the other one with a minus. So this one has 2 and this one has 1. Total of 3 solutions, as promised. So, there was something to this guy after all. Fundamental Theorem of Algebra. The degree of the equation is the number of solutions. Now I bring that up now because it has a lot to do with our class. What does that have to do with our class? Consider an equation like this. Okay? And then consider what would happen if we went ahead and multiplied both sides by x. So you go along, suppose you're solving some equation and then somebody says, hey, we should multiply it by x. It's definitely allowed by the cancellation law of multiplication. But look what happens here. Now you get that x squared is equal to 2x by inspection. Now wait a minute. That one right there was degree 1. So the Fundamental Theorem of Algebra says that has one solution. Now this one is degree 2, so the Fundamental Theorem of Algebra says this one has 2 solutions. Somewhere from here to here we picked up an extra solution that wasn't on the original problem. Those solutions are called extraneous solutions. And you will pick them up every time you increase the degree of the equation. Every time you multiply both sides by x, you've added some solutions. If I multiply both sides by x minus 3, I will increase the degree, possibly adding extraneous solutions. So what does this mean for our class? Well, it means a lot of things. First of all, you should be careful. Every time you multiply both sides by x, you may be picking up extra solutions that weren't on the original problem. The other thing it means is that if you were dividing by x, suppose you would say, okay, I got this equation, I'm just going to do what comes natural here, and I'm going to slap a 1 over x on both sides. 1 over x on both sides. Cancellation law of addition. Well, you should be careful for several reasons, but I'll tell more about that in a second. Here that gives me 3x is equal to 5. And now look at this. So that one, the original problem, had how many solutions? It had 2 solutions. Why? Because it's degree 2 equation. Now this one is degree 1, so this one has 1 solution. What? From here to here, you lost a solution if you went... Well, my fingers are too fat. I think I've gained a few pounds in my fingers. So from here to here, you've lost a solution. The moral of the story is be very, very careful when you're dividing by x's. You may be killing your solutions because you're decreasing the degree for the equation, and the degree is equal to the number of solutions. So just as the same, when you slap x's on both sides, you increase the number of solutions, you pick up extra ones. Same thing when you divide by x, you throw them away and you lose them. That's what it means for a class. You need to be very, very careful. Somebody gives you a degree 2 equation, you should be looking for 2 solutions. Alright, so in this case here, earlier we multiplied everything by 3 times 3 times 2 times 5 times x. If you remember, we multiplied both sides by that because that was the computed least common multiple. So here, what I needed to come back and say is you need to be super, super careful because you're multiplying that side by x and that side by x. And what happens every time you multiply both sides by something that has x's? You increase the degree of the equation, and you may have picked up bad solutions, things that weren't part of the original problem. So my point is that every time you should be conscious, every time you multiply both sides by x's, you should at the end check your solutions to see that some of them might have been picked up in this process. Okay, that's all I wanted to say about that super important fundamental theorem of algebra. Alright, one last time here. An equation with fractions. Okay, so we take our technique here, which was prime factorize the bottom. So that's 2 times x plus negative 3 over 5 times 2 times x, and that's equal to x over 2 times 2. And now we multiply both sides by the least common multiple. I'm going to kill the 2's first. 2's and 2's and 2's and 2's, they will be gone. All the 2's. These 2, that 2, those 2. Next I'm going to kill the 5's. So this will kill all the 5's that are in the denominators. Next I'm going to kill the x's. So I slap an x on everything. And that's cancellation law of multiplication and distributive law that allows me to do that. And it cleans up super, super nice. The 2x goes with the 2x. The 5 2x goes with the 5 2x. The 2 and the 2 go with the 2 and the 2. And what we're left here was the 5, 2, and a 5. Well, that's 10. 10 times 5 is 50. Plus, that's a 2 and a 3. 2 and a negative 3. That would be 5x squared. And so we're left with a nice equation here that has no more fractions. Sometimes you may get x's here. You can use your quadratic formula, ultimate power, if that happens. This one I can do by square root property, so I get that 44 over 5 is equal to x squared by killing the coefficient. And now I can use my super famous square root property, 44 over 55. Whoa, not 55. Just the 5 will do square root property. And there you go. Solving equations. Oh, the other thing I need to tell you is, right here, this step, you need to watch out for. You need to watch out for because we multiply both sides by x. Every time you multiply both sides by x, you need to think you may be introducing extraneous solutions. So to finish this problem fully, you need to take this positive x value and plug it in there and see if it works. And then you need to take the negative one and check it in there to see if it works. That will verify that you didn't pick up any extraneous solutions. Okay, just to be safe. Alright, I think we should call it a day here. We'll see you guys here next time. Peace.